Let's enhance our cube further by looking at other dimension properties. There are many properties on an attribute, and we will cover these in this section. The first one is sort by different member. This property is useful with the month name, which is originally sorted alphabetically. We need to sort the month name by the month number of year. Here we have the option of sorting by a key's value, or another related attribute key or its value. The unknown member is another interesting one. When nulls exist in a column that is a key through a snowflake relationship, the process needs to know what to do with those null values. Analysis Services provides a method for this. Even though the best data modeling practice should have placed not available type in this dimension table, sometimes the cube has to take care of this problem. Alright, now let's talk about attribute hierarchy properties. Here we have a couple of properties that help with performance. The first is the enable browsing property, which tells the cube to create an attribute hierarchy or not for this member. If not, it becomes a member property and is still able to be displayed at the key level of the dimension. The next one is the visible property. We can have the attribute in a hierarchy, but not the individual attribute member visible to the client tools. Optimize provides a mechanism for turning off the indexing of an attribute, and you can use this case when that attribute is not used in the client tools. The last item that we look at is the display folder, and this is to organize related attributes in a dimension. Once many attributes become prevalent inside of dimension, it becomes hard for the end user to be able to select from that list. Some other member properties is aggregatable. This is where the all member comes in an attribute hierarchy. If you learn from the end user that they do not want to have an all level to that attribute, you could change this property to false. When changing to false, you'll also have to select a default member. The attribute hierarchy ordered can be used when the values in an attribute do not need to be ordered in the client tool. We'll see this case for the gender name. Discretization methods and bucket count are a way to organize values from an attribute. If the values become too numerous, you can actually create buckets and ranges for these through this property. The value column is used with the name and key column properties. The value will actually replace the underlying value for the key when displayed in a client tool. The name will still be the value displayed, but its ordering behind the scenes will be done by the value column. Now, let's go ahead and do a demonstration of these dimension properties. Let's go ahead and launch SQL Server Data Tools and open up our project that we've been working on. We'll click Start, SQL Server Data Tools, and hit Enter. Go to the File menu choice to Recent Projects and Solutions and pick the AdventureWorks Data Warehouse. If ending windows pop open, go ahead and close those. The first thing we're going to look at is sales territory and some of the attribute hierarchies. So we'll scroll down in the Solution Explorer to Sales Territory Dimension and open up the Dimension Designer. We'll highlight the Sales Territory the attribute, and go to the Properties window. If we scroll to the top, we'll see that we've made this invisible. So it's not visible to the end user and is not used in any reporting mechanisms. So we can also change it from optimize to not optimize. This controls the indexes that will be created. So we've changed two properties on this particular attribute. The enable hierarchy enabled has to be true in order for it to link to the measures in the cube. We'll save our work and go back to the project and deploy just to make sure those changes didn't cause any errors. Once we're finished with that, there's nothing to display because that was just to improve performance. Next, we'll look at the date dimension. We'll go to the Solution Explorer, scroll down to Date Dimension, and open it up. We'll make the window to the right a little bit shorter so we can get more space in our work area. If we go to the browser and we drill in to the calendar date by year and then quarter, we'll notice that the month is not in sequential order. It's in the alphabetical order. We can change this by changing the order property of that particular attribute. So if we go to the dimension structure to month name and then go look at the properties, we will see an order by column. And right now it's ordered by the key and can be ordered by name. But if we pick something like order by attribute key, we will see the only thing available is quarter. So the first thing we're going to have to do is create a new attribute relationship. We'll go to the Attribute Relationships tab, right-click Month Name, and add a new attribute relationship. We'll change the related attribute to month number of year, and then click, we can change the rigid relationship type, and then click OK. Once we do this, let's go ahead and deploy to make sure there are no errors, since this is a new type of attribute relationship. Once we see that there are no errors and that the month number of the year can be related to month name, we'll go back to the dimension structure, back to month name, and go to its properties. Here, we'll now change the order by to attribute key and the order by attribute property to month number of year. Once we deploy the solution and we don't receive any errors, we'll go to the Browser tab and reconnect to our database. Once we reconnected, you'll see February, January, March will turn to the proper sorting. Now we have January, February, and March. The next item we're going to look at is the unknown member. We'll close the date dimension and we're going to open up the product dimension. Because we let the Cube Wizard create the product subcategory and category relationship, it knows that there's a possibility to be nulls in the related tables. The first thing we'll do is go to the product level of the dimension and go to Properties. Here we'll see the unknown member is now visible. When something is bold, it means it's been changed along the way for a property, and the Cube Wizard did this for us. Another property you see below that is the unknown member name. Right now it's blank, so it'll take the default unknown. If we go to the Browser tab and we pick the product by category hierarchy and we drill down, we'll see at the bottom of the list the unknown member. We'll also have that unknown member under unknown for the categories that are not unknown. And lo and behold, if you drill into that unknown, you will see all the products that have a null value for the subcategory key in the product table. We looked at this in the beginning in our data source view, and now you see the results of why we have to be aware of this. One more thing to look at is in the dimension structure for the actual product subcategory key. If we go down to the property key column and drill to key column and the product subcategory key, we will see that the null processing has been changed to unknown member. This is done also at the product category level, which we can see once we drill down into the product key. So, by default, because we let the wizard create this snowflake schema, we can see the unknown member. Some people might say that we don't need to use a snowflake and use a star, but then in this case the snowflake actually helped us with the processing. Before we finish with this term for unknown member, let's go back to the product level and put NA for the unknown member name and then process the cube. Once we deploy the cube and go to the Browser tab, we will see that the unknown member name now has been changed to NA. So we can control the value that's actually displayed for the unknown member. We can also turn this off and it will not be available at this aggregate level. We're going to close the properties or the product dimension, and now we're going to open up the customer dimension. The customer dimension has many attributes, and if we open up the cube and go to Browse and Analyze in Excel, we're going to see a big list for customers. We can actually organize these items into a display folder. So we'll go back to Visual Studio, back to the customer dimension, and we're going to highlight education, occupation, gender, number of children, total children, and yearly income, all highlighted using the Control key and then clicking on those, and place demographics into the Enable Attribute Hierarchy display folder. Once we deploy this cube now, those items will be organized into a display folder, which helps the end user in the Client tool. We'll go back to Excel, to Data, and refresh all, and we'll now see the customer dimension has organized things into a demographics folder. Let's minimize Excel and close the customer dimension and the AdventureWorks cube. The next item we'll look at is in the product dimension. If we go to the product dimension and our user says we don't want the all level for color, we can go to the color attribute and to the properties and change the is aggregatable to false. What I did there was just double click the property and the values change in the property value. Now I'll deploy that cube and we'll see the effect it has. Once it deploys and there are no errors, we can go to the Browser tab, and now we see that the color by size hierarchy has no all level. If we go to the size attribute, you see the all level, but if we go to the color, it is no longer available. In the dimension structure for the color attribute and in the properties, if you wanted a default member, you could go to the default member and actually add that. So we look at the default member property, click on the ellipse, and we can actually choose one of these values as our default. Or you can actually enter an MDX expression that specifies the default member. We're going to cancel that and change is aggregable back to true and save our changes. The next thing we're going to look at is how sorting happens. So we're looking at improving the performance of our cube. We'll close any open windows and go to the customer dimension. We created the gender name earlier, and this does not need any particular sorting. We do not need male before female, and we don't need female before male. It's arbitrary. So what we can do is go to the basic area and look for attribute hierarchy ordered by. Once we find the attribute hierarchy ordered, we can change the property value from true to false. Next, we'll deploy the cube to make sure that those changes took place. Once we receive no errors and we go to the browser, we will not see really much difference with the gender, because this is just something in the background that controls the creation of aggregation and indexing. The last thing we're going to look at is the yearly income for the customer dimension. For the customer dimension, the yearly income is a display of a bunch of values. Now these values are kind of a long range, and in this case there's not many, but if you have a large employee or customer dimension, these can get numerous. What we can do is group these things through a method and a bucket count. We'll highlight yearly income in the attributes. We'll go to properties. We'll widen that properties and get back on yearly income, and we'll see towards the top of the category ordered list one thing called desegregation method. We're going to pick equal areas, but you can use an algorithm called clustering, or you can automatically let the server create it for you. We'll pick a bucket size of 5, and we'll save these changes and deploy our cube. Once it deploys and there are no errors, we'll go back to the browser and reconnect to our cube. You will see the yearly incomes be bucketed. This is really nice for the end user to get an idea of what can be done. Something like this should be handled in the ETL and Data Mart, but at least you could give something to the end user to look at before you create it in your end product. We're going to go to the cube and display it in Excel. Open the cube, go to Browser, and Analyze in Excel. We'll enable and select some things that we've already created. I'm going to go grab that yearly income just to see what that looks like. And that's a pretty neat thing that you're able to do. I'm also going to go create and grab the order date calendar hierarchy. Now, one nice thing inside of Excel is being able to insert slicers, which we looked at earlier. For instance, we can grab a slicer from marital status, which shows us the difference between married and single people. There's also an insert object called a timeline. And if we pick that, before we pick it, we need to be inside the pivot table. So I'm going to close that window, go inside the pivot table, and click timeline. It's going to give me an error that it can't create it because it doesn't have a formatted date. This is because our date key is an integer, but our name is an actual date. What we need to do is change the value for this. I'm going to click OK, minimize Excel, and go back to the date dimension. If we go to the date key and to the properties and scroll down to the bottom, that is an additional property called value column. We can actually change this value to the actual date rather than the key. And once we deploy this cube, that change will be in our date dimension. We should not receive any errors, and we can go back to Excel, open that previously created pivot table, go to the Insert ribbon, and click Timeline, and now we should be able to go into the timeline. The reason we can't go into the timeline is first we have to go to the Date ribbon and refresh all. This will refresh the metadata columns that tell the timeline to use the value. We go back to the Insert tab, click Timeline, and we're able to pick our order date for this timeline. So rather than having a slicer, now we have a different type of layers to display the values for. We can go years, quarters, or even months, and even go down to the day level. This is neat because you can select one thing and use a slider to pick the values in the timeline.